We're going to start learning about children's mathematical abilities and thinking from very, very early on when we actually start teaching them how to count. And really, counting seems like a really simple part of mathematics, right? Without counting, what could you do? But in truth, it's a very, very complex set of understandings. And children, when they're little, they have to understand a lot of these things in order to bring it all together into counting. More importantly, if they don't understand counting, we as adults need to be able to identify what is it that they are missing. So just to give you an idea of an example of a child who is understanding some things about counting, getting fairly close, they're missing something central that's going to put it all together. I'd like you to watch a video of my son at 18 or 19 months old, counting bunnies at our dinner table. And what I'd like you to do while you're watching that is to try to pay attention to what is he understanding and what is he not understanding.
2, 3, 5, 6, 7, 8, 9, 10.
What's after 10? What's after 10?
17.
13, 14, 15.
Bunnies. Bunny.
Can you count the bunnies on the bunnies box?
Bunny.
Can you count them? How many bunnies are there on the bunny box?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
What's after 10?
Hopping.
You're hopping. How many bunnies are left, kiddo? How many bunnies are left? Can you count? Can you count? 1. Okay, slow down. Slow down. Swallow those bunnies, please. You sneak. Count the bunnies. Count the bunnies on the table.
7, 8, 9, 10.
What's after 10?
11.
What's after? Yeah. 14.
17.
What's after 17? What's after 17?
All gone. All gone.
Bunny's box.
All gone. Bunny's box.
All right, welcome back. So I hope you had fun watching Arlen and got some ideas from him about how complex counting actually is. So let's look at some things that go into counting. So first of all, let's say we have a child that's going to tell us when they count, they're going to tell us 1, 2, 3, 4, 5, 8, 9, 4, 5, 2, 6. And a second child that's going to say 1, 2, 3, 1, 2, 3, 1, 2, 3. What are they understanding and what are they not understanding? So first of all, they are understanding there are number words and there are non-number words. Non-number words. I don't see them saying 1, 2, 3, red, orange, green, 7, 9, cat, right? We specifically see that all of those words that they're saying are actually number words. Now, this is language based, obviously, so if they were counting in Russian, these particular words, 1, 2, 3, would make absolutely no sense. For them, the counting words would be раз, два, три, четыре, пять. This is a cultural thing. They learn it fairly early on. In fact, they learn it at about the same time as they learn some other basic songs or basic words, like the color words, or the alphabet words, or the animal words, or what do animals say, right? So for the first little while, we spend a lot of time identifying different words in our language system that represent different things, and then grouping them and connecting them. So, what are the errors now? First of all, the first child says 1, 2, 3, 4, 5 correctly, and then 8, 9, 4, 5, 2, 6. That child only knows the correct order in which these numbers go, up to 5. And after that, they just say, just throw in some number words. They're all kind of, it's all a mess. So they know the number sung up to 5 only, and the second child only knows it up to 3. So they don't understand the full number song. Okay. They understand it to part. The second child, it seems to only think 1, 2, 3, 1, 2, 3, 1, 2, 3, so they think that this number song repeats. This 1, 2, 3, 1, 2, 3, 1, 2, 3 and repeating pattern is something that we may have taught, his parents or her parents and surroundings may have taught them without knowing that they were teaching them. A lot of the number songs that you will look at on YouTube or anywhere else, or even some posters or books, they'll only count till 10, and then they repeat. So actually, there was one number song video that I was watching, and it actually says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we start again. So it's a cute rhyme, but do numbers actually start again? So giving the kids the idea that this is a repeating pattern may actually be quite problematic, and child 2 seems to have that idea. As I mentioned, children learn the counting song at about the same time that they learn the alphabet song, and about the same time when they learn that, a doggy says woof woof and a kitty says meow meow. So what they're doing is they're trying to group different words into different categories. Like if this is a color word, this is an animal sound word, this is a letter word. And also trying to remember little rhymes, put them in order. If you're looking at the alphabet song versus the number song, what are the similarities that they have? And what are the differences? Go back and try to sing the alphabet song to yourself. Go back and try to sing the number song to yourself. And see how they're the same or how they're different. All right, so in addition to Arlen's example, let's take a look at another group of children that are counting not quite correctly. These are 4 children, and we want to try to identify what's happening. How does what they're missing fit into our counting? So for example, child 1 is going to say, there's 5 objects laid out. He's going to say 1, 2, 3, 4. So pointing and saying the number words at the same time. So you're seeing that there's a lot that's good that's going on, but they're missing something. So number word and point, they have a nice connection here that they're pointing and saying the number word. But what are they missing? Let's look at child 2. The child is going to say 1, 2, point, 3, 4. So the child is pointing at every single one of the objects, but they're not connecting the point and the word. Because here in this middle situation, they pointed, but they didn't say the word. How about child 3? 1, 2, 3, 4, 5, 6. This top connection, every time they point, they say a number. But they are not pointing once and only once to every object. Missing something in this part, in that connection. They're pointing and saying more words as they point than just one for every object. Okay? So those connections have to be 1 to 1. Every time you point to an object, you need to say the word once and point once. So everything just happens once. How about this child? 1, 2, 3, 4, 5, 6. They're having a tough time with this particular, the word and the point. All of these children have some connections between the word, the point, and the object. What some of them are missing is this 1-to-1 correspondence. And that's what it's called, 1-to-1 correspondence. Okay, so all of this this whole diagram here, this connection, all has to happen at the same time. The word, the point, and the object. Right? It all has to happen at the same time, and it has to be one-to-one. So this has to be one-to-one, this has to be one-to-one, and this has to be one-to-one. So all of that is happening one-to-one. I'd like you to write out as a generalization here, or a summary of what we just talked about. So let's move on to the next problem. Let's say we have a child, and you're saying, how many blocks are there? And the child says 1, 2, 3, 4, 5. And you say, how many blocks are there? And the child says 1, 2, 3, 4, 5. And you say, how many blocks are there? And the child says 1, 2, 3, 4, 5. So when you are asking them a question of how many blocks are there, or can you count, they're just going through the motions. They are doing very well with the one-to-one correspondence here, right? All is one-to-one, but they're not understanding that how many blocks are there, that they're going to say 5. They think that how many blocks are there means, hey, why don't you just do that number song and point and thing? If you remember, in Arlen's video, he was doing some of that as well. So how about if we ask the second child, how many blocks are there? The second child has already counted the blocks and understands that the 1, 2, 3, 4, 5 was the process for counting, but the total number of blocks is this 5. 5 objects. Okay, that this 1, 2, 3, 4, 5 exercise wasn't an end in itself. It was there so that you can get the cardinality. In other words, the number of items in the set. So overall, as we're looking at what is needed for a child to be able to count things that are in front of them, it's this. They need to know the words, they need to know how to point, they need to point and say the words in a one-to-one correspondence with the objects. And once they're done, that idea that the last number I said, as I was doing this one-to-one correspondence, is the number of items in a set. Last part of this activity is to look at an example. Say a teacher shows a child some toy bears. So there are 6 toy bears and the child counts. Then the teacher covers up the 6 of them and adds another. Now how many bears are there in all? Some children will be unable to answer altogether. It's hard to tell what's going on in their mind. There's lots of things that they could be confused about. One area where they could be confused is in the object permanence, is that they may not think that when you cover up the bears, that there are still 6 bears under there. Object permanence. That they're still under there. They're just hidden. All right. Child 2 says 1, 2, 3, 4, 5, 6 while pointing to the covered bears, then points at the new bear and says 7, and finally says there are 7 in all. So this child is recounting from memory, knowing that they're under there, recounting the 6 bears. And then counts on to 7. Child C says 6 while pointing to the covered bears, then points at the new bear and says 7, and finally says there are 7. So this child is not recounting the bears, just counting on. Right? So that child understands that under there is 6, and the number that comes after 6 is 7. How many of you sometimes feel like in order to be able to alphabetize something, you actually have to sing the song, the alphabet song, from the beginning, or at least from an earlier part? For example, what comes after Q sometimes, and sometimes I have to say, oh, LMNOPQR, right? So I have to wind up a little bit to figure out what comes after Q. These children they can't figure out that after 6 comes 7 right away. They haven't practiced that yet. They haven't assimilated that yet or memorized it yet. So they have to wind themselves up. They remember the song, but not just a part of the song from the middle of the song. So they would have to say 1, 2, 3, 4, 5, 6, 7. Or some kids might remember, they could say, oh yeah, 5, 6, 7. They just need to wind themselves up a little bit, but they're counting on, they're not recounting the 6 bears. All right, but it's a very, very challenging question that as adults, we don't realize quite how much goes into understanding that. And there's the difference for you between the common knowledge and the specialized knowledge, right, that we were talking about earlier, the specialized knowledge required for teachers. Let's now take a look at, let's say we know how to count, and we know how to count to a long way, 1,000, all right, and we figured out the pattern of, the fact that 21 and through 29 are just like counting by ones, but we're adding 20 at the beginning. And then after 29, we do a switch and we go to 30. And often you will see kids, when you're talking to them, you will see them saying 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay, so they will be winding up. They understand the 1 through 9 goes naturally the way that it used to, but then there's a jump. And they have this, say this 1 through 9 in one breath, and then they hold it, think about what comes next, and then they keep going. And you will catch that very frequently. After a certain time, that stops, and they can actually just count without taking a breath before the next 10. All right, so let's say you were given 1,000 small objects, and whether they're toothpicks or paper clips or thumbtacks or whatever you name it. I usually bring toothpicks to class. Imagine I'm just walking around and dumping toothpicks onto people's desks. And then I ask each of the students to count them and then to organize them visually so that I don't have to count as I walk around. I can see how many toothpicks there are really quickly. Some kids will say, oh, I'm just going to do like a tally mark. 1, 2, 3, 4, 5. And that's the way they actually line them out. 4 this way and 5th that way. Right? So I can walk around and I can say, you have 23 toothpicks. That's pretty easy. But then, if I dump them all together, will it be helpful for me to have the tallies? I'm going to be walking around and I'm going to have to count by 5s. It's not going to be a quickly visual way to show, right? So if we all put our toothpicks together, I'm still going to have to count by 5. So I'm going to have to say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 67. That's not a visual way to show me. However, there are some more visual ways that we can do. We can try to make it look a little bit more like our number system. Well, our number system will have, and I'm going to use toothpicks because they're easier to draw. So if we have 10 toothpicks, in our number system, we bundle them. Mm-hmm. So we will say up to 10, so if I have 9, I'm going to leave them loose. But as soon as 10 happens, I'm going to take those 10 and bundle them. Notice I just drew 3, but imagine that those are 10 toothpicks bundled. Okay, so that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now, when I'm putting this 20th down, that is going to get grouped into another bundle. Right? So that's 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. As soon as I put 30 down, I'm going to have another bundle, etc. And let's say that we had 32 on one desk. When we put all of ours together, then we're going to have a whole bunch of these 10 packs. Mm-hmm. And what happens with the 10 packs? Well, what if I have 10 packs? Right? I could group those again based on our number system. And if I group those again, I'm going to have to group them somehow. I could either make a big bundle, but that's going to get confusing, especially when we get a little lazy with drawing. Or how could I actually put together or keep together 10 bundles of toothpicks? Is it possible to do a Ziploc bag? maybe I'll put 10 bundles of toothpicks into a Ziploc bag. And that's going to be my 10 bundles. And then I might have some of these left. And then I might have some, let's see, a couple more bundles. And then I might have some singles left. So remember this, so the singles are the 4, but I also have singles bundled up, right? And I have 5 of those bundles. And I have a bunch of those bundles in a bag, right? And I have 1 of those bags. So we can do this and organize our numbers, fairly large numbers, in this kind of format. Could it have been paper clips? Absolutely. And then we could use paper clip. Do you know they make these, like you can take a paper clip and put 9 paper clips hanging off of it, right? And that would be your bundle of 10. You could do that, and then the single paper clips would be singles. Okay, you could certainly do that. But sure, we can do that in many different ways. But the idea is still going to be the same. We're going to take the ones, the loose ones, and then we're going to group them. And then we're going to take those 10s, and then we're going to group those. And we can take those 100s as well, and we're going to group them. We can group those with a big elastic band around the Ziplocs, however you want to do it. So if you give a child a kindergarten a bunch of counting chips and ask the child to show you what is the 2 in 23. So the child might show you 2 of the counting chips. You might be tempted to respond that 2 really stands for 20 and not 2. It's true, but 2 does stand for 20, but there's a way you can respond to it as draw attention to the base 10 system. So how would you do that? So if you say 23, and you ask them what the 2 stands for, the 2 there represents 2 what? 2 in our toothpicks, 2 of the bundles. So if that's 2 of the bundles, then that is 20 singles. So, and that's connected more towards our base 10 system because we're not just saying it's 20, we're saying it's 2 what, right? We're saying that this place value means the bundles, and this 3 is talking about the single toothpicks. And if we had another number on the left, we would be talking about the Ziploc bags. So draw a rough picture showing how to bundle 137 toothpicks so that the way the toothpicks are organized corresponds to the way we write the number 137. Okay, so the 7 is going to represent our singles. The 3 is going to be our bundles. And the 1 is going to be our Ziploc bag of bundles. And there'll be 10 of those in there. Okay, so 1 of the bags, that's 100. 3 of the bundles, that's 10 each, and 7 singles. And explain why the way the bagged and loose toothpicks pictured here are organized does not correspond to the way we write that number of toothpicks. So let's see. If we did write that number of toothpicks, we have 15 and 12. So this is our 10s and this is our 1s. So if we wanted to say this number, it would be 12T 15. 12T 15 because we added T after our 10s digit and then we say our 1s digit, 12T 15. That's certainly a number, and in fact that form of that number is something that I use with the kids that are just starting to count, because they might say, when they're counting, they might say, 39, 30, 10, 30, 11, 30, 12, 30, 13. So this is not out of the ordinary at all. Or if you say 9T, 10T, 11T, 12T, 13T, they would go on and they would get past 100 with the T words. And that's quite natural as well. But unfortunately, even though our system could work that way, there's nothing wrong with it. It's not how our conventions work. So instead, we say we can only go up to 9 of our loose numbers. So we can only go up to 9 here. Okay, and as soon as we get to 10, we have to bundle. So what's actually going to happen is we're going to take a 10 from here and we're going to bundle it into there. And the kids will say, great, 13T5. 13T5. Perfect. Well, not quite, because that number can also only go up to 10. So we would need to take 10 of them and bundle them into a Ziploc bag, for example. So then we would have 1 Ziploc bag, 3 10s, and 5 1s. So it'd be 130, which is 3T. And what I'd like to point out to you is that there's nothing wrong with this number and this number. Those numbers are correct, except that they're not the way we have decided that we're going to write numbers. But if the children are beginning to think about it this way, there's nothing wrong with that. And moreover, we will use these 12T15 and 13T5 when we're doing subtraction, because we will be regrouping. So this is a very important step in the children's understanding.